Why don't we spend a little bit of time now to understand the difference between SQL and NoSQL? So I'm going to show all the characteristics of SQL because this is something that we are quite familiar with, right? And even if you're not from the relational database background, that's totally okay. In fact, I can go out there and say that if you're not from relational database background, you're probably better off working with Cassandra because Cassandra is so different. The way you need to think Cassandra is very, very different than an RDBMS. So the more RDBMS you know, the worse off you are in Cassandra. So this is the typical SQL characteristics. Relational, we've got joins, foreign keys, referential integrity, unique keys. It's a master-slave model. In databases, you typically have a single entry point. And that entry point, the server hosted at that entry point, is responsible for all your transactions. In fact, Cassandra is so different that I'm not going to use the word transaction. Of course, there is something called as lightweight transactions, LWT in Cassandra, but it's neither lightweight nor is it transactions. So don't let some of these terms throw you off again. So let's compare that with the typical NoSQL characteristics, especially Cassandra. It's a data store in my mind. It is definitely distributed. Rarely will you see, actually you probably won't see at all, Cassandra implementation which is a single node. It is non-relational. Data is stored in key value pairs. And I'll show you the physical data structure on the disk, that why this is very important for us to understand. Cassandra on many occasions is referred to as a flexi schema. It's actually not. You have to define a table. In that table, you have columns and you store the data in those columns. If a column is not there, you cannot store the data. It's just like an RDBMS. You define a table and for those columns, you store the data. No joins. So when you're talking about Cassandra select statement, you really do not have the ability to say the from clause with multiple tables. You cannot do that. And it's a great thing. It's horizontally scalable. Compare that with RDBMS. And here's a key term that we must keep in mind: low data density. What this basically means is when we create a Cassandra cluster, the objective is divide and rule. Divide the data among many small commodity class machines and rule your data. The whole idea is if one of these machines fails, my impact on the overall system is minimal. Furthermore, if I can use replication factor, a term that we're going to talk about, but broadly, it indicates that I'm not going to store the data just once. I will have multiple copies of that data sprinkled across multiple nodes. So if one node does go down, as I mentioned, I'll have the attitude, I'll just shrug my shoulder. Okay, that's fine. I still can get my data both in terms of reads and writes from the other replica nodes. And I cannot achieve that in a vertically scalable model. I need horizontally scalable model, small units of data, and then spread it across the cluster. So in the previous couple of slides back, when I talked about that Apple cluster, 75,000 nodes, 10 petabyte of data, if you do a simple division, you'll see the data density per node is about 133 GB. 133 GB is nothing, don't you think? 133 GB of data can potentially be cached in memory. If you have a 512 GB RAM machine, the whole data can actually be cached in memory. You can imagine the kind of velocity of access you're going to get. Low latency. This is yet another important term. designed for access patterns. This basically indicates you would like to organize the data the way you would like to fetch it. It's literally RDBMS turned upside down. In RDBMS, you usually create the data structure. You remember the entity relationship modeling? You do that and then you create the query. It's exactly the other way around here. In other words, the right questions to ask when you want to work with Cassandra would be, let's not worry about what the table is. Let's see what the use case requires. Oh, looks like this particular use case is going to have the order ID. And based on that order ID, I need to fetch the record. Okay, there you go, one table. Oh, the same order can be fetched based on the customer ID as well. Okay, that's a different access pattern, which means there's a different table. So think of it like this. In Cassandra, you're going to do data duplication, data denormalization, pretty much for all the use cases. And that is totally okay. The reason why it's okay is because you're organizing the data that will deliver the right performance benefits for that use case. Imagine this. Next time when you switch on Netflix tells you, right, that you were watching that movie and you had paused at that particular hour, minute, and maybe not second, hours and minutes. There are millions of users using that system, Netflix. Imagine if you just switched on the TV and the wait cursor is spinning in the middle of the screen. Say, wait a minute, I'm trying to figure out what you watched the last time, and it takes several minutes to get there. What is going to be your impression of Netflix? If you go to an e-commerce e-commerce website, and the list of past orders that you placed, it's taking minutes to load, what will be your impression of that e-commerce organization? See, these are expectations we have. If the page doesn't load of a particular website in a matter of seconds, we all get pretty jittery. We get impatient. These are the real requirements of modern enterprise. It is because of us, it is our expectations that is driving the need for this kind of modeling. So classical RDBMS obviously cannot deal with these kind of expectations. Cassandra can be tuned for great read as well as high availability write systems. And I'll prove it to you during the read path and write path why that is the case. And in order for Cassandra to keep delivering low double-digit microseconds, reads and writes, what exactly it has to do behind the scenes. Data replication, I already talked about that. We are not going to store data in a single copy. We are going to have multiple copies. So therefore, the next question could be, how many number of copies? What is the exact figure in terms of the number of replica we should have without going overboard? We're going to talk about that. Here's a huge difference. Unlike an RDBMS, Cassandra is a masterless model. In other words, there is no single entry point. We do not have a single master with a secondary. It's a masterless model. It's a peer-to-peer system. You can get in touch with any node. You can connect with any node and start interacting. When I say interacting, CRUD operations. You insert, you delete, you update, you select. CRUD operations. Any node. And because of this, we have no downtime. Of course, this particular statement has to be taken in the context of the actual implementation strategy. So will there be a downtime for a specific data set? Could be. But from a system perspective, there is no downtime. Imagine you have 10 nodes. If one of the nodes go down, because it is masterless, do you not have the remaining 9 nodes to interact with? Yes, there is no downtime. But the application which is talking to the node that just went down, can that particular operation have a little bit of jittery time? Yes. We will also see what are the techniques and tools Cassandra offers to get around that problem. Let's take a look at where these characteristics can be applied. There's actually no single rule. You can use Cassandra for high read oriented applications, high write oriented applications. You can actually use Cassandra to store documents too. But will you be able to fetch the data based on certain attribute of that particular document? The answer to that question is no. Cassandra, think of it as a giant hash map, and I'll explain as we move on forward that why we need to start thinking like that. If you want to be a great user of Cassandra, you really need to start thinking hash maps. And the way you typically deal with a hash map in a programming language environment. This is the second time I'm going to mention that, and I'm going to mention that several times as we move on forward. You really need to know your access patterns up front. You need to know how you're going to fetch the data from the system. And then based on that, you're going to create models, aka tables, to organize the data that will give you blazing performance for those access patterns. And folks, make no mistake about the last bullet. If you get started with a particular model without really thinking through, making changes to that model really hard as we move on forward. So you most likely will have to create another table and do data migration from the older table to the newer table. Table and model, these two are again synonyms, at least in the world of Cassandra it is. Now, so far what we have seen is what really drives Cassandra. Of course, we're going to take a look at how it works internally. But this should set the context in terms of the basic needs of the enterprise today, the basic needs of social applications, basic needs of e-commerce applications, IoT applications. The needs are very different than what it used to be in the past, and therefore the world of databases had to evolve to take care of some of these realities. Now, there is a very important aspect that we need to understand apart from the reasons why NoSQL, the world of NoSQL and some of these approaches existed. So why don't we take a look at that?